Snyder, Bill, Manu, Snyder, Bill, Manu.
So we might fail to appreciate this, but the idea of the invention of radio was perhaps contributed by telephone itself. And soon enough after Marconi's invention, the first radio factory was established in Chelmsford, Essex, and a link between Britain and France was discovered. Let's get started with the block diagram of the FM radio receiver, and the first thing that we come across is an antenna. It is an electric device which converts the radio wave into electric power, and actually the power of an electromagnetic wave is used to produce tiny terminal voltage, and this signal, now in the form of tiny alternating voltage, goes to the RF amplifier. Now coming to the working of RF amplifier, let's explain. Since the detector works more efficiently with the larger signal applied, thus we should first amplify the signal before feeding it to the detector. A RF amplifier amplifies the frequency signal. The frequency at which maximum gain occurs in an RF amplifier is made variable by changing the inductance or the capacitance of the tuned circuit. An RF amplifier can tune over the desired range of input frequency. Now this signal with the amplified frequency of the radio wave goes to the next part, that is the mixer, where the signal is fed into a circuit where it is mixed with a sine wave from a variable frequency oscillator known as the local oscillator. The mixer produces both sum and difference beat frequency signals, and its output has the frequencies FRF, FLO, that is the local oscillator signal, and there is one frequency FRF plus FLO and one FRF minus FLO. Here FRF is the frequency of the radio wave that we have received. Now these mixed frequencies are sent to the next part, that is the IF amplifier and the filter, and these signals are now applied to a fixed intermediate frequency, that is IF amplifier and filter. Any signals that fall within this passband of the IF amplifier will be amplified and passed on to the next stages. Those that fall outside the passband are rejected. Tuning is accomplished very simply by varying the frequency of the local oscillator. The advantage of this process is that very selective fixed frequency filters can be used, and these far outperform any variable frequency ones. Now these selected and desired frequencies are fed into the demodulator, and the demodulator recovers the information contained from the modulated carrier wave. Here the desired frequency is separated from the frequency of carrier wave, and hence we get the required frequency with the minimized signal loss, and this required frequency is the one that we were trying to tune into. And finally this signal goes from the demodulator to the AF amplifier, that is the audio frequency amplifier. The output is the recovered audio. The output from the modulator is the recovered audio, which is then amplified and sent to the headphones or the loudspeaker, from where we can listen to the music or the FM channel that we have tuned into. So this is the detailed and quite possibly the simplest circuit for a FM radio receiver. So first comes up the antenna. which converts all the EM signals in its niche to the alternating currents which is friendly to the circuit. Right, so coming to the RF amplifier, the basic functions include the amplifying of the waves and acting as a coarse filter through providing a short bandwidth. How is this done is that the inductor and the variable capacitor, which you can see in the figure, form the frequency close to which the bandwidth is formed, and the BJT acts as an amplifier for the same. From there, coming to the oscillator is gang coupled with the RF amplifier so as to provide a mutual and an individual frequency to work with. So it provides the same frequency to the mixer as well. Now the main part of the mixer is that it gets input waves from the oscillator as well as from the RF amplifier and provides a mixture as per say F1 plus F2 and F1 minus F2, F1 and F2 being the separate in frequency. So after this, the output of the mixer goes to the IF amplifier or the intermediate frequency amplifier, which consists of two op-amps basically, which is in the middle given by an RC circuit which acts as a band-pass filter. So these op-amps basically amplify, and since they are in the non-inverting mode, provide you with an amplification which happens twice to get a good input of the included frequency. Okay, so this particular demodulator is the Foster-Serley demodulator. You can see it takes the input across the capacitor, and also it has a reactance in the center of the circuit which is very high, so as to provide this the minimal amount of variation in accordance with the input. Also, there is a variable capacitor to provide the natural frequency for the given voltage which is coming from the input. So what the basic aim of the demodulator is to keep the amplitude proportional to the change in frequency. And why this is done? This is primarily done in order to separate the information that was modulated on the carrier from the carrier wave itself. After all, we want to get only the things that we wish to get. So in lieu of that, the demodulator functions accordingly. Now finally, the frequency that we have been looking for, we have got it, and now we send it to the next level, that is the AF amplifier, that is the audio frequency amplifier, so as to amplify the frequency of the direct audio thing that we are going to tune into. And so finally we get it into our headphones from there, and that's it. That's how we do it. So about the answer to this question, tuning into any of the frequencies considering 93.5 Red FM, what we do is we basically change the variable capacitor through the tuner which is present in the exterior to the circuit. What that does is, since the frequency of resonance is 1 by 2 pi under root LC, so on changing the capacitor we can tune into the desired frequency, and the circuit is set for the same. So we are trying to set up a resonant LC circuit which which only picks up the frequencies that are nearby under root 1 by omega 1 under root 1 by LC. That is, we are changing the C to get this frequency near to 93.5 megahertz, and these nearby frequencies we pick up and they are processed in the later stages to get the final purified signal in a better way.